So welcome to 0.3. In 0.2, we were adding integers, fractions, and decimals. Today we'll be subtracting them. So do these problems. So hopefully that is an example of two opposites being added together, which is what property? The inverse property of addition. And 16 plus negative 16 equals 0. Now, number 2 is from, what, second grade, right? Maybe first grade. And whenever you see that in a warm-up of mine, it's not because I don't think you know how to do 16 minus 16. I am trying to teach you a pattern or show you or remind you of some pattern in math. And the easiest way to get you to see a pattern is use easy numbers. So it turns out both of those equal 0. Let's see if that pattern continues through this warm-up. Four minus 9 is not 5. I get algebra students even who think that. No. 4 minus 9 is negative 5. If you try to take 9 away from 4, you're 5 short. You're at negative 5. So far, the left column and the right column are having the same answers. Now, number 8 is what we're doing today, as well as number 6. And so what is negative 7 minus negative 13? Well, negative 7 minus negative 13 is the same as adding positive 13. It's called adding the opposite. And so number 7 and 8 also have the same answer, 6. It turns out that subtraction and adding the opposite are always the same. So let's look if that's true everywhere in this warm-up. So, right, if you have the first number the same in each problem, here's subtracting 5, here's adding the opposite of 5, and you got the same answer. Here's subtracting 9. Here's adding the opposite of 9. Same answer. Here's subtracting negative 13. Here's adding the opposite of negative 13, positive 13. You will always get the same answer, as subtraction is always the same as adding the opposite. Okay. There are 3 properties from yesterday. Can you name them? So there's what I just said, right? Notes. You can take the notes exactly the way they're written, or you can shorten them. But what I don't need you to evaluate the expression. I need you to copy these 3 problems down, and I want you to do what it says to do. Evaluate them. So that's 15. That's positive 15. All right, now 9 minus negative 4 is the same as 19 plus 4. So that's not the same as the other ones, okay? So subtracting 4 from 19 is the same as adding negative 4. Those two were equivalent. Let's do that again. So negative 43 plus 7, well, 43 minus 7, that's negative 36, so that's not the same. So subtracting 7 is the same as adding negative 7. Oh, these two are going to be equivalent. Right? So adding the opposite isn't just a way to get the answer in Algebra 1. We are going to be switching back and forth between adding and subtracting, and you have to understand how to do that. Is that subtracting will always be the same as adding the opposite number. All right, so evaluate that. So on your homework, I expect to see you converting it to adding the opposite. I want to see that work. And then I want to obviously see the evaluation, the answer. You're evaluating an expression, right? So you change the subtraction to adding, the second number to its opposite. The first number stays the same no matter what. So that becomes adding. This becomes its opposite, which is negative 40. And so the answer to this is negative 6. Now, there is no commutative property of subtraction. These are not equal, right? These are not equal. And in fact, what happens is you get when you switch a subtraction problem around, if you take x minus y and you have y minus x, these will have opposite answers always. That's a 7. So that's the same as negative 37 plus 32, which is negative 5. 5 extra negatives. Leave the first number the same. That becomes adding. 12 becomes its opposite. All right. So negative 47 plus negative 12, negative 59, right? If you can do it in your head, if you can do it in your head, great. If not, you do a little side work. But this is what I want to see on your paper. So which two are equivalent? Have to be. Well, let's change that one to adding its opposite. It would be x plus the opposite of y. So that's the same as this one. This one we change to adding the opposite, we get x plus y. That's not going to be, unless you have special numbers that add up to 0 or something, that's not going to be equivalent to the other two. For all values of x, x plus the opposite of y will always equal x minus y. So we have the opposite of a minus b is the same as opposite of a plus the opposite of b. The opposite of a minus the opposite of b is the same as opposite of a plus b. So which two are the same? These two are always going to be equivalent. This screen here is a good taste of what you're doing this year. You have to be able to understand the rules, not just get answers. That's the big difference between algebra class and the math you've done up to 7th grade. Add the opposite, keep the denominator, add up 5 plus 2, you get 7/9. Keep the first number no matter what. You add the opposite. Opposite is positive 1/11. We're going to keep the negative 4 up top. And we get negative 3/11, and you can put that negative sign either atop or in front. Either is acceptable. Keep the first number the same. Add the opposite. So in the numerator, we have negative 3 plus negative 1 over 8. We get negative 4/8. What's wrong with that? It's not simplified. The only correct answer here is negative 1/2. We are always simplifying our fractions in all situations. Never ask a teacher that again. With decimals, same rules. Add the opposite. So 9.3 plus 0.7. We're lining up our decimal points. We're carrying this 1 over there and making 10. And so I do this problem specifically because I get weird answers on this. And 10, don't tell me the answer is 10.0. That's not better than 10, right? The answer here is 10. The opposite of 7.8 is negative 7.8. So I like to, on these, wherever I'm planning to write the answer, put the negative sign. Just if I'm going fast, I might forget that. So So then I'll come over here maybe, and I realize, oh, it's 1.3, but it's negative 1.3 because we have 1.3 extra negatives, right? If you switch that around, you get 1.3. When you switch subtraction around, you'll get the opposite answer. All right, so here's what I've been saying all along. X minus y, as a rule, you could put numbers like if you put 6, if x was and y were 6, you could get the same answer. But as a rule, x minus y will not equal y minus x because there is no commutative property of subtraction. So 9 minus 2 is 7. Now, when I'm doing these for my own use, I just look at that and go, well, it's got to be negative 7. But what's going on, and you can do the same, right? What's going on there is 2 plus negative 9, right? 2 plus negative 9 is negative 7. Now, this has order of operations in it. Which do you have to do first? Right? This is a tie. When you have a tie between operations, you have to go left to right. Only when there's a tie, though. 10 minus 7 is 3. 3 minus 1 is 2. Right now, let's see if we get the same answer when we switch it around, right? Because we switch it around with addition, we get the same answer. 7 minus 1 is 6. 6 minus 10, negative 4. No, you do not get the same answer because there's no commutative property of subtraction. So we're at practice. Do all 4 of these problems before I put up the answer. Right, the bigger absolute value number has to go up top. You can't do 65 up top there. And so this is negative 16. Right, 217 plus 5 is 222, but there are 222 negatives there. Oops. Right, if only we could do that in our head. 24.7 minus 4.7 has got to be 20, right? And that's 20 extra negatives. What property is that if it's true? Right, 18 minus 6 is 12. This is negative 12. It's not true. We can say false or not true. Do not write the word commutative. Don't. Why? Because this is a big deal for you in geometry class next year. Properties tell you why things are true. They don't tell you why things are false. All right? So you just write false or not true, depending on what your teacher wants. Final question. 3 of those will always be the same for all values of x. All right, there's a good use of the commutative property, right? The commutative property of addition says you can switch that around. If it's subtraction, you can't. But since it's addition, you can switch it around, and it's the exact same as the first 2. Thank you. Do your homework.